Hello and welcome to all students. In this lecture we learn about real sequences and some bounded and unbounded sequences. So first of all we define what is meant by bounded sequence. A sequence xn, a sequence of real number xn is said to be bounded sequence if there exist m small m and capital M, these are real numbers, such that xn is greater equal m and xn is less equal m. It is true for all n belongs to n. The meaning is that the sequence xn is said to be bounded if all terms of that sequence they are in between two real numbers. Two finite real numbers. So let us define what is meant by unbounded sequence again. A sequence which is not bounded is called an unbounded sequence. We can call a sequence bounded if and only if its range is bounded set. It follows from the above definition that sequence xn is bounded if and only if there exists capital M greater than 0 and it belongs to R, such that mod of xn is less than or equal to m for all n belongs to n. So this is about a bounded sequence and unbounded sequence. Before this, we will define what is meant by a sequence which is bounded above, a sequence which is bounded below. Okay. So here, depending on the terms of sequence, the sequence can be classified into bounded and unbounded sequences. Okay, the bounded and unbounded sequence, these are classified by using the terms of the given sequence. So let us define sequence bounded above now. A sequence xn is said to be bounded above if there exists a big real number m belongs to R, such that xn is less equal m for all belongs to n, for all n belongs to n. This means that a sequence is said to be bounded above if the all terms of that sequence they are less than or equal to some real number, some fixed real number or some real number. Okay, the number m is called an upper bound of sequence xn. Now we define a sequence bounded below. A sequence xn is said to be bounded below if there exists a real number small m belongs to R, such that small m is less equal xn for all n belongs to n. The number small m is called an lower bound of sequence xn. The number small m is called a lower bound of sequence xn. In other words, a sequence of real numbers is said to be bounded below if there exists a real number m such that all terms of that sequence they are greater than or equal to that real number. All terms of that sequence they are greater than or equal to that real number m. Here small m is called as a lower bound of that sequence. Now we are in the stage to define a sequence which is bounded. A sequence xn is said to be bounded sequence if there exist two real numbers m and m, small m and capital M belongs to R, such that xn is greater equal small m and less equal capital M, and it must be true for all n belongs to n. Now let us define a unbounded sequence. A sequence which is not bounded is called an unbounded sequence if at least one bound does not exist then we say that the sequence is unbounded. Means if there exists a lower bound but there is no upper bound, then that sequence is called as a unbounded sequence. If there exists upper bound but does not exist lower bound, in this case also we say that the sequence is sequence is unbounded. Okay, and if there does not exist both lower bounds as well as upper bounds, in this case also we say that the sequence is not bounded or sequence is unbounded. Okay, we can call a sequence bounded if and only if its range set is bounded set. It follows from the above definition that sequence xn is bounded if and only if there exists capital M, there exists a real number m greater than 0 such that mod of xn is less equal capital M for all n belongs to M. Let us consider some examples. Question number 1. Examine whether the sequence xn is equal to 1 upon n is a bounded sequence. Examine whether the sequence xn is equal to 1 upon n is bounded sequence. So let us write the answer of this question. So it is, so to show that the sequence is bounded, geometrically we can represent it very well, because all terms of that sequence they lies in between 0 and 1. Okay, so first term of that sequence is 1, which is upper bound of that sequence, and the remaining terms of that sequence, they are approaching towards 0, and therefore the lower bound or greatest lower bound of that sequence is 0. So there exists upper bound as well as there exists lower bound. Upper bound is 1 and greatest lower bound is 0. Therefore that sequence is, we can say it is a bounded sequence. So by using the definition of bounded sequence, we can show that sequence is bounded sequence since n is greater or equal 0 for all n belongs to the set of natural numbers. Therefore 1 upon n is also strictly greater than 0 for all n belongs to n. So see here step by step, and n is greater or equal 1, and this implies that 1 upon n, this reciprocal must be less equal 1. 1 upon n is less equal 1, and it is true for all n belongs to n. Therefore what happens, so 1 upon n is strictly greater than 0 and 1 upon n is less equal 1. It is true for all n belongs to n. Or we can say that xn, so 1 upon n is nothing but nth term of that sequence xn. So xn is strictly greater than 0 and less equal 1 for all n belongs to n. Therefore our final conclusion is sequence xn is bounded sequence with 0 as a lower bound and 1 as a upper bound. Okay, therefore given sequence xn is equal to 1 upon n is a bounded sequence. Let us take next example. Example number 2. Examine whether the sequence xn is equal to 4 upon n plus 1 is bounded. Examine whether the sequence xn is equal to 1 upon xn is equal to 4 upon n plus 1 is bounded. So let us again we try to show this sequence is bounded sequence. Okay, so we guess that, so what is the first term of that sequence? So first term is for n equal to 1 we get first term means x1, and that x1 is equal to 4 upon 2 plus 1 means 4 upon 1 plus 1 means 4 upon 2, and 4 upon 2, x1 is equal to 4 upon 2 means 2. So x1 is 2. As we are putting n is equal to 1 2 3 4 5 6 7, the terms of that sequence become smaller and smaller because we are adding into the denominator. Okay, so that sequence again approaching towards 0, so first term is 2, and the greatest lower bound of that sequence is again 0. So sequence is bounded by 2, sequence bounded above by 2 and sequence bounded below by 0. Therefore this is also a bounded sequence. So let us write the answer of this question. Since n plus 1, that number is always strictly greater than 0 and it is true for all n belongs to n, and this implies that 1 upon n plus 1 is greater than 0. Reciprocal is also greater than 0 for all n belongs to n, and n is greater or equal 1. This implies that n plus 1 is less equal to. So is it clear? So since n plus 1 is strictly greater than 0, its reciprocal is also greater than 0 for all n belongs to n, and as n is greater or equal to 1, therefore n plus 1 will be greater or equal to n plus 1 will be greater or equal to for all n belongs to n, and therefore 1 upon n plus 1 is less equal 1 half for all n belongs to n. So 1 upon n plus 1 is less equal 1 half for all n belongs to n. So multiply by 4 to this inequality and see what do you get. So if I multiply by 4, then we have 4 divided by n plus 1 is less equal 4 by 2, that is 2. So 4 upon n plus 1 is less equal to for all n greater or equal n, but the term xn, they are strictly greater than 0, therefore 4 upon n plus 1 is greater than 0. So we observe here that the terms of the sequence xn, they are bounded by two real numbers 0 and 2. Therefore the sequence xn is equal to 4 upon n plus 1 is bounded sequence with 0 as a lower bound and 2 as a upper bound. So this is about the bounded sequences, and let us stop here. Thank you for listening this lecture. Thank you very much.